Hello, we're going to use LabVIEW to create a new virtual instrument, or VI, and it's going to be used to be able to interface to the myDAQ, some digital and analog I/O interfaces. So the first thing you have to do is open up the software, and you'll get these two panels. And the way I was able to do that is I went to Window and do Tile Left and Right, so that you have these two panels. And what these two panels are, one on the left is called the front panel. The one on the right is called the block diagram. This one, the left side, is going to be the user interface, and the right-hand side is where we'll actually do the programming. Step is to create a while loop. So to do that, I come over to here, select Structures, While Loop, and I create an area that I'm going to work in. And then the next step is that I want to add a stop if true, or create control. So I do that. I'm just going to move it over a bit. Notice here that it doesn't seem to connect to the left side input. So to fix that, you can just right click and clean up wire. That's something you're going to do very commonly. And the next step is, this is the iteration. I want to put an indicator. Same thing here. The indicator seems to come at the bottom, so I'm going to clean it up and just do clean up wire. All right, so that's my very basic loop. And if I run this, and we don't want to use run continuously, use just run. And what you'll notice is this counter moves very, very quickly. So I'm going to stop this, and then I'm going to add a delay timer. I could put wait and the amount of milliseconds. I'm just going to come over and right click here and click create a constant. And we're going to make that constant equal to 50. Now when I run this, it's going to be a little bit slower. You can see that the count. So what this is doing is counting the iterations of this loop. So that's the very basic thing that you want to do first. My next step is to adjust these icons that I have on the front panel. I just move them. I can move them around, and I'll put the stop down over here. Okay. The next step I want to do is to add some controls and indicators. And the first one I want to add is a control. So I can do this on the front panel. And I'm going to go to Silver, Numeric, and it's a numerical control. And I want to make it a vertical pointer slide. And we have to put this on the front panel. So that's going to be my control. And I want to change the scale so that it only goes to 5 volts. So to do that, I just click on the 10, change it to the 5, and now I just have that range. If I want to make this a little bit larger, I can do this with my mouse. And now we have a slider that we're going to use to control the voltage. And I'm just going to move this around here. And the next thing I want to have is an indicator. So the indicator, and I'm going to go back to the silver. I just like some of the types of scales they use here. And so I'm going to use a gauge and put it here. And I'm going to leave it at 10 volts for now. So if I wanted to test these two items out, I would just make sure that I have the gauge over on the right, the pointer slide on the left. And notice here that the arrow is pointing outwards. That's a control. And this one is pointing inwards. That's an indicator. And I connect the two together. And the orange wire is telling me that it's a data type that's real numbers. The blue are integer values. The green is Boolean value. So now that I've got these two connected, I press the play button. And if I move this slider up and down, it's controlling the gauge. Okay, so all seems to work as expected. Great. Now I will add a Boolean control and a Boolean indicator. So over on the left-hand panel, right click and go to Boolean this time. And we're going to start with a control. I'm going to use a toggle switch over here. And if I want to change its size, I can use the manual tool. So you'll notice that Sometimes you have a little hand with a finger pointing. Sometimes you have the crosshair. Other times you'll have a sizing tool. So what I want to do is select this device, and you see there's little handles that I grab onto, and I can make this switch a little bit larger. Maybe that size is okay. Now over here and under the View tab, you'll see something called the Tools palette. So I've turned on the Tools palette. When this is green, it means that it automatically chooses the correct tool. And there are tools like wiring tools, control tools, adding text, changing colors, and so on. So for now, I'm just going to turn this off. But that's how I can have it see right now. That's the control, so I can move this up and down. If it changes to this pointer, it's resizing, and so on. So the next thing I want to add, by right-clicking, going to Boolean, is a square LED. I'll put that LED here. And you'll notice again that if I click on it, you'll see a resizing handle come up, and I can make that a little bit bigger. Okay, if I wanted to change the names, this is where I would do it. But for now, I'm not going to do that. So I've added those two items. So now let's come over to the the block diagram. And I'm going to separate these a little bit. And you'll notice that this is the control. It has a darker outline. It's in green and has an arrow pointing outwards. I'm going to connect it to the indicator. And now when I run the program and I control the switch, it changes the LED. But we want to have it being controlled by hardware, and that's going to be our next step. Now we're going to add the DAQ assistant so that we can actually control the hardware on the myDAQ. To do that, you right-click on the block diagram, go down to Measurement and I/O, select the DAQmx, and then the DAQ assistant, and place it between those two items. Okay, this just takes a second, and this is an express VI. That means that we're actually going to configure the VI. So I want to generate a signal, so I click down and expand here. An analog output, we're going to control the voltage, and we want to select the channel we're going to use. So it's analog output channel 0, and then click Finish. Okay, now I don't want to control it with a sine wave, so this is important. You've got to come down here on this scroll bar, and over here select one sample on demand. Okay, one sample on demand, and I'm going to write, just to do this test, 3.2 volts. Let's fix that, 3.2 volts. And I want to change the range setting here. I want the maximum to be 5 volts and the minimum to be 0 volts. So 0 to 5 volt signal. This just means it's reference single-ended. You might want to read this a little bit. Make sure this is set to one sample on demand. And if I click on Run, and you were to measure that analog output pin, you should be seeing, I'm going to do apply value to all, but you should be seeing 3.2 volts. For now, I'm just going to stop this. And now that I've configured everything, so maximum, minimum, one sample on demand, and I've given it a name, I can change the name here as well. And once I've done that, click OK. Okay, and what that does is it configures that DAQ assistant. That'll happen in just a few seconds. Now, once that's happened, we can connect this over to the vertical pointer slide so that when I move this slider up and down, it's going to send that voltage out to DAQ 0, channel 0. Now we're going to add another DAQ assistant that's going to be used to read the data from the analog input and send it to a gauge so we can actually see the voltage. So just like before, you right-click on the block diagram, Measurement, I/O, DAQmx, DAQ assistant. So it's another DAQ assistant, but we're going to be changing the configuration to read data from the real world. Okay, so this time we're reading, so we're acquiring data. It's going to be an analog input, voltage. We're going to select the channel, and I'm going to use analog input channel 0. And this is a differential input, so you must make sure that the minus input is connected to the analog ground. Okay, so there's a few things here. I normally always open up details. Make sure this is set to 1 sample on demand. And you can see here it's analog input 0. You can change the name here. If you want to rename or change the physical channel, this is where you would do that. And if I want to test it, I come up here and just say run. Okay, you'll notice it's measuring 3.2 volts because in the previous step, that's what we output, and we have the output connected to the input on a jumper wire. So that's why we're reading that voltage. Once we think we have everything okay, then we click the OK button. Okay, it does its thing, and it's eventually going to have a connection to this. So we're getting the data from the real world, and we want to connect it to a gauge. And notice this blue wire, that type of data is called a dynamic data type. Okay, and it's sending it to a gauge. So let's just see what happens. So over here, I'm going to run this. And I'm going to change the vertical slider so that we have about 3 volts. And you'll see that that's what is happening. And that's only happening because we have the jumper wire from analog out to analog in. Okay, if I move that slider up and down, it's operating the controls properly. So great, everything's working the way it should. Now we're going to do the same thing for the Boolean control and indicator. Right now, it's just connected in software. You can see as I move this switch, that goes back and forth. One of the other things that I can do that's kind of useful is to put a probe here. And if I just put a probe, what it allows me to do is if I'm only looking at the block diagram, I can move this back and forth. And you can see that the probe is telling me the state of that wire. Okay, it's actually measuring that wire that connects the two. So I'm going to remove the probe for now. And I'm going to also remove the wire. Sorry, I got that probe there. I'm going to stop the program. When you make changes, you have to stop the program. I'm going to click on the wire. And there should be a delete wire. Okay, and so I've done that. I'm going to move these over a little bit to give me some space to add the DAQassist. So I'm going to start off by adding the DAQassist to control a Boolean output. Okay, so I'm going to go to Measurement IO, DAQmx, DAQassist, place it on the page, not too far away from the Boolean control. So I've done that. Just have to wait for it to initialize. And so here we want to generate a signal. So click on Generate a Signal, digital output this time. And we're going to do line output. That's just a single bit at a time. So there we go. Now select, make sure not the simulator. Some people make mistakes on that. And we're going to do, we only have one port, and it's going to be line 0 or bit 0. Add it here. Okay, and it says 1 sample on a demand. Let's open up the details because the details tell you where it's connected to. myDAQ 1, port 0, line 0. And we can actually run this. I might have to bring this down a little bit. So this is the digital output. If I click on run and I do this, it's actually controlling the voltage to that pin. So this turns it on, gives it 3.3 volts. That turns it off. The LabVIEW uses low voltage TTL signals. So logic low is 0, a logic high is 3.3. Once I have that tested, make sure you hit stop, click OK. And so now we have the DAQassist to be able to control an output bit with our Boolean switch here. So then we have to connect this to that. And oh, notice we're getting an error. And that error is because the DAQassist, well, we can actually go up here and see what's causing that error. It says these cannot be wired together because their data types are different. The type of sync where it's connected to is a one-dimensional array. So we have to change it to an array. So let's close this. And notice this is an indication of broken wire, so I can do Control key plus the letter Control B. That removes broken wires. So what I need to do is to add an array in between these two. So to do that, I'll bring this a little bit closer, go up to arrays, and we want to do something called build array, which is right here. And I'm going to add this. And this is just one element of an array. And that's all I need for this because I only have one input. So I'm just going to have one. One other feature you should always do is to put visible items and a label so you know actually what that is. So now I'm going to try connecting this element. Notice right now it's orange, but it'll change to green when I connect that, and it did. And then I'm going to connect this to the build array. This time I don't have any errors. Okay, so it's working as I expected. So let's do the same thing for the indicator that's on the screen right here. And to change that indicator or be able to get the data to display it on the screen, again, I have to go to Measurement IO, myDAQ MX, DAQassist, place it on the page. Okay, and this time we're going to acquire a signal. Okay, we want to get a signal from that pin. Okay, we have a pin going from D0 to D4. So we're going to read it on D4. So this time it's a digital input, line input. And since we have the jumper wire going from 0 to 4, I want to select line 4, and I've done that. Okay, open up the details, make sure it says one sample on demand. And if I bring this down a little bit, if I click on run, whatever state that pin is at, and right now I can't change it because my program's not running, it'll turn green if it's high and dark if it's a low. Okay, so all that seems to be okay. Click OK. We're going to have the same issue that we had before with the array because the DAQ assistant for digital inputs and outputs are arrays. So when we try to connect this to that, we're getting an error. I can come up here and see that that's what the error is. Close that. Do Control B to remove the broken wires. Let me do that again. Okay, Control B removes broken wires, but now we need to go to that array palette and go to index array. We're going to put index array there. And right now I only have one element. Okay, and this is the array. It's going to be an array of digital devices, and this is the single element out here. And that's going to connect to the Boolean. And what I can do out here is this is going to be our virtual switch. And we can resize that so we have all the text. And this is going to be our LED, a virtual LED, but it's going to let us know what's happening on bit 4. I can even put bit 4, and over here I can add bit 0. The more information you have, the better it will make things when you go to control things. And this is coming from analog input 0, and this is controlling analog output 0. Okay, so let's actually change this to analog. It's very easy to change the text. And another thing you may want to do is I will always want you to put your name on the block diagram and the front panel. So to do that, you'll find it under right click, decorations, and label. And this is where you can put your name and the date, September 9th. Okay, and you can do the same thing over here, but I think it's in structures, decorations, free label, and I'll just put my name for now. There we go. Okay, so I think we've got everything set up and running. And notice when I change the names on the left, change the names on the right-hand side. So now when I do this, okay, so now it's physically running. And don't forget, what's really important to understand here is I have a jumper between bit 0 and bit 4 of the digital, and analog output 0 and analog input 0. So now when I move this slider up and down, it changes the voltage. I can change the scale there, but that's fine for now. And when I move this switch up and down, it changes the signals. So for the digital, it's either 0 or 3.3. Okay, so I think that's all okay. To add a digital display to the analog inputs and outputs, you'd come over to the icon for the slider, right click on it, go to visible items and digital display. Same thing here, digital display. Very, very useful for testing and troubleshooting. But notice that, you know, this, the one digit after is 1/10 of a volt, 100th of a volt, 1,000th of a volt. We're not measuring that accurately. Okay, it's probably best to go to just 1 or 2 significant digits. So I'm just going to go to 1 for now. So to change that setting, you can actually go to display format, and you have to click on the digital display. And we're going to select digits of precision. Okay, and we're only going to have 2 digits of precision, so that's important. And we're not going to hide the trailing zeros. We want to see the trailing zero. And we're going to go to floating point. So let's just look at that again. We want to make sure it's the digital display, because you can use the drop-down menu to go to the numeric input. And we want to have it as floating point, 2 digits of precision, turn off the hide trailing zero, and then click OK once you've done those changes. Okay, so now when I run this and I move the slider back and forth, you'll notice that it's only going to 2 significant digits on that display. And if I wanted to do the same thing for here, I'd stop, right click, visible items. No, that's not what I want to do. So we want to be able to change the properties, and we're going to floating point, and let's just put 1 digit of precision on that. Okay, turn this off and leave it at digits of precision, which is fine. So now you can see that we have just 1 digit of precision there. Let's try running it again. Okay, good enough for the kind of things that we're doing here. We could do it over there, but let's get rid of all these digits here. So stop again and go to properties or display format. Either one of those will work. Floating point, 2 digits of precision, and then right here and OK. And so now you see the same thing. If I wanted to add just the 1 digit there, properties, floating point, 1. There we go. So now let's maybe just move these around a little bit. I can put this text over here. The other thing that you can do is if you group these together and you come up to here, you can resize objects, distribute them, align them. So let's say I wanted to align these at the bottom. That's doing that, especially if you have 3 things of the same type in a row, but this doesn't look so good. So I'm just going to move this up here. Remember what I said too, under View and Tools Palette, you can turn things on and off or just use the text writing tool. So normally you want this tool to be green so that it's automatic. And I'm just going to turn it off. Our next step is to add an Elvis meter, and to do that you have to run the NI Elvis instrument launcher. You should have downloaded Elvis by now, and there are many different types of equipments. The oscilloscope, function generator, you get a scope that looks like this. Let me open this up and close that. Digital multimeter is going to be very handy for what we do because it allows you to do screen captures. Okay, very simply. So I had to hook up the digital multimeter test leads to the ground and to the analog signal. And on my meter, I want to make sure that I've selected this button. So you got volts AC, amps AC. So we need to have volts DC. I'm going to specify the range. It even tells you here where to connect things. And I'm going to change the voltage because you'll notice here that we only have 1 digit of precision. So that's the 60 volt scale, but I'm going to switch to the 20 volt scale. And in a few seconds, you'll see now it has much higher precision. Make sure this is set to run continuously. This is stop, this is start. So I've started it. So I've got my meter connected. And remember, there is a jumper wire from analog output 0 to input 0. So now I'm going to move this slider around. I'm going to stop it at about 2.05, and that's what it's measuring. So very accurate. It's telling me that I've set the voltage to 2.05, and that's actually what I'm measuring. So that's great. Okay, and so if I move this slider back and forth, that's the voltage that I'm measuring. The next thing I want to show you is I'm going to move a jumper wire here from the analog signal to the digital signal. I have a little opening in my wire that I can connect the test lead to. And you'll see here that it's measuring, previously I said that a logic high is 3.3 volts on the myDAQ because it's low voltage TTL. So the switch is high, measuring 3.2. So it's outputting 3.2 and measuring, 3.3 and measuring 3.3. If I bring it down, it goes to 0, back up, it goes to 3.3. And I think that's just about it for the demo today. Thank you.